Can you believe that this little drop of blood, or even a single strand of hair, holds all the genetic information available to find out who we are? Within this drop, we can use the DNA to find out who our parents are and what trait we inherited from each of them. But how is this done? Let's take a look at some of these scenarios and find out.
This is Dr. Hanratty.
Hey Doc, how are you doing?
Good. How are you, Joel?
I'm doing well. I have a pretty good set of calves this year. Interested in actually getting some of them registered, but I have to prove parentage to the association, and actually had a little bit of a mix-up with my record keeping, and so I'm actually kind of unsure who the sire is. Is there any way we can maybe run a test to figure that out precisely?
Yeah, of course. So we will just need you to send in some blood samples of all the potential sires, and then we'll go ahead and run a parentage test to find out who the baby's daddy is.
Awesome, that sounds great. We'll make that happen. Thank you. Bye.
In this envelope, we have the blood samples of the 3 potential sires to send to the lab. It's important to include all potential sires to increase the accuracy of finding our baby's daddy. Let's check out some scenarios that rule out some impossible sires.
Okay, so let's take a look at scenario 1, which is coat color. He sent in 2 samples for 2 of his cleanup bulls. One cleanup bull is black and one is roan. Basing this on genetics behind a coat color, a black sire and a red cow could make a black calf because black is a dominant allele. Even though we don't know if the bull is big B little b or big B for black, he still has the big B to pass on to the calf and make it black. The roan one, however, can't. The red allele for coat color has to be present in homozygous form to give a red calf. The same is said for the white pattern of the animal. When present together in a heterozygous, the red and white form, the animal has co-dominance of the 2 alleles. Since this animal does not have an allele for black coat, he cannot be the sire of our black calf, and he can be excluded from this test. The black cleanup bull, however, needs to be included. Alright, so let's take a look at scenario 2, the accident. Dun dun dun. One common scenario that seems to happen to every rancher once in a while is that the neighbor's bull decided the cows in some poor rancher's pasture looked more appealing. In this case, the neighbor bull broke through your fence on August 30th. Compare that to the birthday of the calf on May 8th. This would mean that 9 months ago, the cow was bred on August 3rd. That was before the bull broke into your pastures, so she couldn't have been bred by him. So he is also excluded from this test.
Third possible scenario is a tank confusion. There was another sire in the semen tank that could have potentially been used by accident. The tank records show that 5 cows were bred on the same day, 3 to Do-It-All and 2 to Jetstream, who are both black sires. Someone quit keeping track, so there are 2 cows that don't have a sire match, one of which happens to be our mom in question. When we take a closer look into the tank, we can inventory the remaining straws and see that each bull was used as expected. There are 7 remaining Do-It-All and 8 remaining Jetstream. So since 1 straw from each bull is unaccounted for and both are black, we can't conclusively decide which sire is the dad to our calf without looking into the full genotype. So both AI sires need to be included in the test. So our actual test for Joel's calves are running in the lab. We're going to do a small scale example to show you what the test is actually looking for. We have our calf genotype here, and we're comparing it to the dam genotype and the 3 potential sires that we established earlier. If you look at locus A, you see that the calf has a big A and a little a, and the dam only gives 2 big A's. So the sire has to have a little a somewhere in his genotype for him to be a potential sire, and all 3 of them do. When you get down to B, you see that the calf is big B, and the dam only has 1 big B. So the sire has to have a big B in his genotype too. 2 of them do, but this one doesn't. So he can be eliminated as a potential sire because he doesn't match our calf. When you get down to C, the calf is little c, the dam is little c, and the only other option for an allele is another little c, so the sire also has to have a little c, and both of them do. When you get to D, the dam is big D, the calf is big D, So the sire has to have a little d, and this one does not. So he can also be excluded as a sire at this point. We're going to look at the final locus just to make sure the calf is little e, the dam is little e, and the sire is little e. The only combination you can get from these two is little e, and that's what our calf is. So this is our family.
Hello.
Here are your parentage results.
Thank you. The moment we've all been waiting for. And the daddy is Do It All.